Welcome to 1D Kinematics Comparing Graphs. All right, so we're going to be comparing a lot of graphs today. I know it's a lot to take in. We took in a lot of information over the last 2 lessons, and now we're going to try to just go through it again and make sure we're understanding. So here we have various graphs, and so we have position time graph, velocity time graph, and then here's like a diagram of what's going on. So you can see that for our position time graph, we have, here's our reference point and here's our person. And they're standing a little bit away from the reference point in the positive direction, but they're not moving, they're just standing there. So here we have a constant position that's away from the reference point. And since they're not moving, what is the velocity? The velocity is 0. Okay, and if we wanted to also draw the acceleration, you would know that the acceleration would be 0, right? Because the velocity is constant. Now here, very similar situation, where here's our reference point, and now they're on the other side. So it's very similar, but now they're on the negative side of the t, and this would be the same. Okay, so now we have somebody who starts away from the reference point. This is their starting point, but they're moving, okay? And you can see from this line that they're moving at a constant rate, which means you're going to have a constant velocity. And you can see that it started not at 0. It started off the t, off the axis. Now here we have the same thing, but it's going in the negative direction. It's going to the opposite direction. And so you can see that the velocity therefore would be negative, would be on the negative side. Here's another one. And here you can see that this is the reference, that this side is positive and this side is negative for the flag. You can define the direction. Typically, north is positive and east is positive, but you can, if you choose to, you can come up with a different system as long as you label it. Okay, so it looks like from these diagram over here that it looks like he's accelerating because you can see how the arrows are getting bigger, right? So he starts away from, he didn't start right at the flag, he started away from the flag, like here. And his position is increasing rapidly, exponentially, as he goes. And so you can see that, and it's got a constant velocity. So the velocity started from rest, so you can see that it started at 0 because he started at rest, and then he has a constant velocity. And this is, again, the reverse. He's going the opposite direction, so everything is just flipped around the t-axis. Okay, so here you can see that he's starting fast and slowing down, okay? So, again, he starts not right at the reference point, and his position is, oh my goodness, I keep messing up with this. And his position is changing, and you can see that he starts with a higher velocity and is slowing down till he stops. So you can see that the position is going like this, and once the velocity changes, the position is just going to stay constant. And again, it does the flip for the other side. Any questions?